Dimensional analysis is physics built in spell check. Before you solve an equation, the units can tell you whether the equation is even allowed. A length cannot equal a time. An energy cannot be added to a velocity. Every term in a real formula has to speak the same unit language. Write dimensions in brackets. Length is L, time is t, mass is m, speed has dimension L over t, acceleration is L over t squared. Force is ml over t squared. Now here is the powerful trick. Sometimes units almost solve the problem. Suppose a pendulum has length L, gravity g, and period t. We want a time. Length L has dimension L, gravity g has dimension Lt to the minus 2. Try L over g, its dimension is L divided by Lt to the minus 2, which becomes t squared. So the only time scale is the square root of L over g. The full formula has a number in front. T equals 2 pi times square root of L over g. Dimensional analysis did not find 2 pi, but it found the shape of the answer before calculus began. It also catches nonsense. If a proposed pendulum formula contains mass, units say no, mass has nowhere to cancel, so for small swings the period cannot depend on the bob's mass. The deep idea is scale invariance. Change meters to centimeters, or seconds to minutes, and nature does not change. Correct equations survive every change of measuring stick. So when a problem feels complicated, ask the humble question first: what dimensions could the answer possibly have? Units are not decoration. They are symmetry, written in everyday language.